Hello class and welcome to your Cambridge Biology Part 1 exam review. This exam is fairly easy, so I'm not too worried about how you'll be doing. Just make sure to study, and a lot of the questions are aligned to the practice questions that you had. Again, I will not give you the exam code until you finish all of your assignments. I need to make sure that you're ready because you only have 3 tests and your final to make up your final grade. And I want to make sure that my students that are B this time around get an A, so you're able to boost up that GPA. So let's get started, guys. If a molecule is blank, it'll be attracted to water and mix with it. So we know hydrophilic means water loving, so obviously hydrophilic will be one of our answers. Water is polar, so water is polar. Remember, like dissolves like, so when water reacts with water, it is going to be polar. And the last one is charge. So you actually do mix with water when you have a charge. This is just because it is an ion, and it normally makes things polar, so charged as well. So the multiple answers that you'll see with this one: water mixes with polar, hydrophilic, and charged particles. If a molecule is blank, it will donate to a proton. So the little visual that always helps me remember from acids and bases, here you have an acid. It donates to a base, that hydrogen ion. So acids donate and bases accept, right? So looking at that information, try to come up with your own answer. So for this one, if a molecule is an acid, it will donate a proton to a base. So our answer would be A. So again, that little visual should be able to help you. And remember, acids donate to the bases and bases accept. If a molecule has both a hydrophilic and hydrophobic parts, but the hydrophilic parts on the outside, will it mix with water? So this type of structure is actually very common in molecules in our body. So what you have is the head is hydrophilic and the tails are hydrophobic. The tails are away from water and your heads are with water. So what you see here is that they definitely will mix. A lot of our biological process have this. So yes, they will mix because the hydrophilic tails are the ones on the outside. So many desert-dwelling reptiles have hydrophobic scales on the outside of their body. Why would a desert reptile want hydrophobic covering? So look at this one truly, guys. So again, hydrophobic has to do with water. We would not look at A because it's talking about sun rays. Water loss, it definitely will do that for hydrophobic, and protection from acid rain. Although we do deal with water with rain, it's not specifically acid rain, so our best answer would be B. A lot of those desert dwelling animals are very, very high heat where water can evaporate easily, so if they have that hydrophobic covering, it takes a lot more time for them to become dehydrated, so they want to maintain as much water as they can. So medicines that can be swallowed, digested, and diffused into the bloodstream, what properties do they have? Remember, our blood is 92% water. So hydrophilic means it loves water. Hydrophobic and nonpolar do not like water. And if our body is it is 92% water, what you want to see is a water-loving substance. So they have to be hydrophilic. How many functional groups do you see here? So this is very important, making sure that we understand our functional groups. So here we have our first one. This is an example of a methyl group. Remember, methyl is simply C and 3 hydrogens. Those are very, very common. Our next group really does stand out just because of the way that it is bonded. So you have a carbon with a double bonded oxygen. So this is a carboxyl example. That double bond is what really does it for me to make it easy to identify. The next one that we have is this amino. So again, that nitrogen makes it very easy to identify your amino acid. They break up your amino acid. And lastly, we have our OH, which is our alcohol. Our OH is also a little bit easy to identify. So this is our alcohol or hydroxyl. So again, you will be giving a question on the exam where you have to look at it and identify the different functional groups. So amino, methyl, carboxyl, and alcohol. This was part of your notes. You can always go back to your assignments and look at those notes, and it'll definitely help you. So an amino, if you look under amino, this one is a base. It has basic properties. So amino has basic properties. Why does amino have basic properties? That lone pair on the nitrogen is actually a hydrogen acceptor. So that is why it has those basic properties. Methyl is non-polar. It is a hydrocarbon. It just has carbons and hydrogens. They do not mix with water. They don't want anything to do with water. So they are non-polar. Next we have carboxyl. So carboxyl, just within the name, it is an acid. And then alcohol has that OH, so it makes it polar. So again, just go back and study those vocabulary. It'll help you a lot. If a molecule is hydrophobic, we know that hydrophobic repels water. It does not attract, and it has absolutely nothing to do with phosphorus. So it repels water. How many hydrogens are present in the phenol-ethyl pyrimidine? So this is just this one that we have here. We can simply circle them. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have a total of 13 hydrogens. If they do the line and stick model, that's probably what they want you to see. Now, here is our line and stick model. So what you see here is that we have an OH or HO. We have 1 carbon and 2 carbons. So we have a carbon which has 2 hydrogens. And here we have a carbon connected to 1 hydrogen, and then an oxygen. So that is the formula there. I can only have 1 hydrogen because that double bond, that's 2, 3, so I can only have 1 hydrogen. This one, we can really tell that this is a carboxyl because our carbon in the center here is bonded to both an alcohol and double bonded to an oxygen. So that's how we know that our second example is the carboxyl looking one. So again, it's just a matter of looking at the structure and trying to match it as best you can. So match the following words to the definitions. Proteins that attach to foreign bacteria and tag them. So we know this would be antibodies. A physical separation of contaminating substance. So for this one, you can just connect it and think about purifying water. So this is purification. Proteins that increase the rate of reaction by lowering the activation energy. This is something we've probably seen in some of our past biology classes or anything like that. So that is an enzyme. And lastly, it is present in the greatest amount, and it is often water. Our universal solvent is water. We should know that from our solubility lessons. So yes, again, just use context clues to help you with those. So for this one, this is our line model. Remember, each peak, 1, 2, 3, 4, 5, 6, tells you how many carbon you have. Remember, carbon can only bond 4 times, so that's how we're able to determine the hydrogens. I'm going to use blue. So this carbon already has 1 bond, so it has 1, 2, 3, 4, 5, 6. It has 3, 7, 8, 9, 10, 11, 12, 13, 14. So the formula for this one would be C6H14. Again, it can only be connected to 3 lines. The little blue lines indicate hydrogens. For B, I have double bonds. So I have 1, 2, 3. I can only draw 1 hydrogen for each. I have 6 carbons, so it's C6H6. And this last one, this benzene ring, you will definitely become familiar with it in organic chemistry. So it has 2 bonds already, and I can only give it 2 hydrogens, so it's C6H12. So again, C6H6 is B, C6H14 is A, and C6H12 is C. That is our benzene ring. All amino acids have which functional groups? So we should know this. This is very common. We do not deal with carbonyl groups, so hopefully that helps, or amides, so that only leaves us with B, the amino acid. Amino acid and carboxyl group, and then it's the R chain. Which is true of the following statements regarding acidic molecules. So remember A to B. So they donate hydrogen ions, right? They donate hydrogen ions. So except we do not deal with helium atoms. This is not nuclear energy. So they donate protons. That would be B. So an amino acid has an amino group on its side chain. What would be one of the properties? This, again, is part of your notes. Make sure to look at those notes where it talks about amino acids continued, and it breaks it down very, very quickly. So amino acid that has a side chain containing an amino group is called lysine. And the properties of lysine are it has a positive charge, it is basic, and hydrophilic. So it loves water. So if it is hydrophilic, which is not a property, it would not be nonpolar. It has to be polar because remember, polar is what mixes with water. So because it is water loving, it has to be polar. We already know that it's charged and that it is a basic. So a hypothetical amino acid has a methyl group. A methyl group. We know methyl is nonpolar, right? So if you make that connection, automatically when you think of a methyl group, it is a hydrocarbon. And it hates water. It is hydrophobic. So for this one, we quickly know it is nonpolar. For the rest, you just have to study the functions, just connect it. I've already put the answers for you. The exemplar would be uploaded. So hopefully all of this helps, guys. Honestly, the exam is pretty simple. Just make sure to study, look over the notes, and finish any missing assignments. I'll be sending you directly the exam password so y'all were able to test. I'll open it later today. So good luck, guys. I hope you have a great holiday weekend. Bye. Stay safe.